Hello, in this session we'll see a problem based on the property of coefficient of regression. So it says compute the regression coefficient from the following data on the variable x and y of 8 such pairs. So the data given is with n equal to 8, summation of xi minus 45 is equal to 48, summation of xi minus 45 square is 4400. Summation of yi minus 150 equal to 280. Summation of yi minus 150 whole square equal to 167432, and summation of xi minus 45 product with yi minus 50 yi minus 150 is equal to 21680. So we are provided with all this data and we need to find the regression coefficient from this. Now let us say that if you assume that u is a variable which is given as x minus 45, and similarly v is a variable which is y minus 150. So what we have done is we have shifted the origin of the xy plane here so that we get ui as x minus 45 and vi as y minus 150. Now we also know that the property of coefficient of regression is not varied if the origin is shifted, whereas it is varied only when the scaling is done. So with the assumption that ui is xi minus 45, we can see that from the given data we will have summation of ui is equal to 48, summation of ui square becomes 4400. Similarly, summation of vi will be equal to 280, summation of vi square will become 167432, and summation of ui times of vi will become 21680. So from these data, and of course n is equal to 8, from all these data we can find the value of u mean, which will be equal to summation of ui over n, and that is 48 over 8 equal to 6. Similarly, v mean, which will be summation of vi over n, this becomes 280 over 8, and that is equal to 35. So with this we may find the variance of u and v both. Now since sigma u square, which can be given as 1 over n times of summation of ui square minus square of u mean, this will be given as 4400 over 8 minus 6 square, and that comes out to be equal to 514. Similarly, we may calculate sigma v square, and that will be equal to 1 over n times of summation of vi square minus square of v mean, and that will be equal to 167432 divided by 8 minus 35 whole square, which comes out to be 19704. So we have found the variance of u and the variance of v also. Now since the understanding is that covariance of uv will be given by the expression summation of UIVI over n minus U mean times of V mean. This becomes 21680 divided by 8 minus 6 times of 35, and that is equal to 2500. Now, as we were talking about the property of regression coefficient, that it is independent of the change of origin, it only matters when the scaling is done. So we can say that the regression coefficient Byx will be equal to BVU, and that will be equal to covariance of UV divided by the variance, that is sigma U square. So as we have found all these values, this will be equal to 2500 over 514, which is equal to 4.86. Similarly, we can say that the regression coefficient of x on y, which will also be equal to BUV, will be covariance of xy divided by the variance of v. So this is equal to 2500 divided by 19704, and this is equal to simply 0.12. Now these are the values we were looking for, that is the regression coefficient of y on x and the regression coefficient of x on y, and we have found with the use of property that the change of the origin doesn't change the regression coefficient. So that will be the answer for this question. Thank you.